Hello, folks. We are on our next lesson, which is on linear measure. It's broken up into 2 days. This first one is specifically on line segments. After today, you're going to be able to recognize and define betweenness of points and use it to write algebraic relationships among segment measures. We'll talk about line segments being congruent and explain the difference between that and equality. So let's first break it down a bit. A line segment. So a line segment is a part of a line. It can be measured because it has two endpoints, and we use those endpoints to name the segment. So remember, a line goes on for forever, whereas a line segment has a start and a stopping point. So like in this case here, our two endpoints would be A and B. So when you name a line segment, you use its endpoint. So this could be either segment AB, and you put a little segment on top so you know it's a line segment versus like a line or something. Or you could do it the other way, BA. And again, make sure you put that line segment on top. Otherwise, it could be 2 points, it could be a line, it could be an array. Make sure you indicate that it's a segment. The measure of segment AB is just written as AB, which I know is kind of silly. So if you were asked to find the length of this, and let's say it was 5 right here, so they told us it was 5, I don't know, inches. How you would write that in a problem, you'd put AB, so segment AB equals 5. You don't put the segment bar on the top when you talk about its length, okay? It's kind of just like capitalize the first letter of every sentence you start. It's just kind of notation thing, okay? So these first examples are pretty quick. It just says find the length of the segment. So it's just like using a ruler, right? This is on the millimeter side here. So if we wanted to find the length of it, this would be about, do you guys say what, 42? It's about right there. It goes to about 42. And then since we have the units, label it millimeters. Pretty standard, right? We'll try another one here. Find the length of segment CD. So this is an inch, so CD equals, so we have a whole inch here, then it goes a quarter more, so 1 1/4 inches. And again, you guys, I will apologize till the end of time that my board just does not like me. So that's supposed to be 1 1/4 inches. So this next slide isn't in your notes, but we're going to talk about it real quick. It says, which point in this diagram is clearly between the other two? So we have a lot of points here, right? Remember, a point is just a dot with a capital letter next to it. And my question to you is, which point is clearly between the other two? And you could go about this a few different ways. You could say F is between E and D, right? I mean, it appears to be that way. Or same thing here, C looks like it's between B and D. However, there's only one real answer to this, and that would be that B is between points A and E. And the reason for that is, you guys, is it's because they're on the same line. They are collinear. So the order for a point to be between two other points, they have to be collinear. We don't for sure know that this would line up perfectly for C to be on line BD. Compared to my crooked line I just drew, it could be, but we're human error, right? We don't for sure know. So you would have to make sure that they are on the same line in order for it to be between. Which brings us to our next point here. So betweenness of points says, let's scroll over so you guys can read this. There we go. Point N is between points P and Q if and only if P, Q, and M are collinear. And this will be really helpful. We'll use this a lot in these first 2 chapters. Because now, since we know this, we can break apart segment PQ. So can we agree that we have this huge segment PQ, right? And now I can split it into its pieces, its parts. So I would know that PM right here plus MQ would give me the length of the entire thing. Again, purpose of this is now, since I know that M is between these 2 points, I can break apart the bigger segment into 2 smaller pieces, and that will help us when we're trying to solve for variables and lengths and things like that. You'll hear me say this a lot, in geometry especially. A picture is worth 1,000 words, and it helps if you label your pictures. Don't be lazy. A lot of you are so used to being able to do things in your head. You sure can, but you will find that you will make way more mistakes. Take the time to label your pictures and draw them out. I promise you will make way less mistakes. So like on your notes here, you don't have this segment. I suggest that you draw this picture that you see here. It will definitely help you. And now I'm gonna label. It's as if Rn equals 12 and Rb, all of my segment is 40. We are looking for Nb. So now I know that my whole segment RB is equal to Rn plus Nb. And now I'm going to plug in what I know. RB, they told us equals 40. Rn, they told us is 12. And we're looking for Nb. And now you guys have a really simple linear equation to solve. So now I want to get x by itself by simply subtracting over 12. If I subtract over 12, we get that x equals 28. So NB equals 28. And then we're done. Let's try another one. So again, I have this picture, you don't. I would draw it. So we have Rn is 2x. NB equals 19. And the whole thing equals 4x plus 1. Again, since I know n is between r and b, I can write rb equals rn plus nb. And now we can substitute in what we know. rb equals 4x plus 1. Rn is 2x. Nb is 19. And then we solve. So remember, when you solve, you get your variables to one side and your numbers to the other. So I'm going to bring over my 2x. We have 2x plus 1 equals 19. Subtract over 1. 2x equals 18. Divide out. Oops. 18 divided by 2, folks, is 9. So, I don't know, is that what they wanted us to solve? Let's make sure we answer the question. Find x and rb. So we just found x to be 9, and then rb we can plug in. So rb equals 4 times 9 plus 1. 4 times 9 is 36, plus 1 is 37. So there we go, folks. X equals 9, rb equals 37. Perfect. Okay, we will do this next example together in class, so you just hang tight. We will do that together in class. And then last thing we want to talk about before I let you go is congruent segments. So it's exactly what you think it is. If you know what congruent means, it means that they're like identical, the same. So congruent segments will have the same length. In a picture, we indicate this by these little slash marks. So like, you guys see these little slash marks here? Those are telling us that segment AB is congruent to CD. Congruent is a little bit different than equals. So if we have, so let's say, do you guys see how both of these segments are 1.7 centimeters in length? So I could say their lengths are equal, right? Because they're both 1.7. However, if I want to talk about the segments themselves, I would say segment AB is congruent to segment CD. So their lengths are equal. I don't know if you want to put that. Lengths are equal, but the actual segments are congruent. Whoa. Again, my board, you guys, it hates me. Okay, that's it for notes. Like I said, we will finish up that last example in class when I see you. Have a super day, and we will see you when I see you. Goodbye.